Okay, sorry. So, lesson one overview. Our objectives is to learn fractions, real numbers, properties of algebra, percentages, and interval notations. All this will be on that exam, well, not the exam, on that little quiz that we're supposed to do on Friday this time, not tomorrow, Friday. Okay. Important details about the syllabus, the main gist of it, right? You could read the syllabus if you want. If you didn't get my email, come to me after class and I'll email it again. It's going to tell you like when the quizzes are, when the homeworks are, what subjects or topics we're going to learn during that day, and what else, and when the exams are going to be. Homeworks and quizzes will be done on Lumen OHM. You can find that on ohm.learning.lumenlearning.com. And for now, there's a 2 week grace period, so you don't have to pay for it yet. If you decide to stick with the course and go on further, then you will have to pay $35. But to log in, you have to use the course ID, which is 93696, and the enrollment key, which is 1219. There will also be a total of 4 exams and one final. The final is counted twice, and I'll drop the lowest grade. Office hours will be Tuesday and Friday from 3 to 4 at the Dolciani Math Center. That's located on the 7th floor of the library, which I'm pretty sure I'm supposed to say East Building. I'm pretty sure it's the East Building, but I'll double check. If there is an issue, you can always make an appointment or talk to me and we'll work something out. If you aren't able to come during 3 to 4, classwork will be done and collected after class. It will be marked as a participation grade, so you are expected to come to class every single day. If you don't, please email me if there's an issue or there's a problem. It's worth 5% of your grade, and I will return it with revisions and feedbacks. For accommodations, please talk to the Office of Accessibility and send me an email that approves your accommodations. Other than that, should be good. I can't emphasize this enough, though. Once the Dolciani Math Center opens up, which will be next week, um, I will not only have my office hours there, but you should also come just in case you don't understand anything. There's a lot of math tutors there that are very knowledgeable, very good. And like I said in today's class, math is a subject where you kind of have to know what's going on in the first class in order to understand the next topic and the next topic. So if you feel kind of iffy or not sure about one topic done during that class day, please seek help so then you could better prepare yourself and understand the next topic. I want everybody here to obviously pass. Um, all right, so please ask questions. Don't be afraid. If you are kind of shy and don't want to ask in front of the whole class, meet me after class. Talk, explain. I'm more than happy to help. All right, so we'll review with fractions, kind of like a quick overstep. So we're going to learn how to add, subtract, multiply, and divide. Right? There's two parts of a fraction. There's a numerator, which is the top number, and denominator, which is the bottom. The way you remember, denominator starts with D, so it's the one that's located down, right, or below the fraction. Okay. Another key note that we must remember, right, is that a fraction can never have a denominator that's equal to 0. So if we have this fraction, this 3 cannot be a 0. So we can't have 0 there. We can't divide by 0. It will be an error. And if we want to write a whole number as a fraction, we have to simply put it over 1. So we have an example here, like 4, right? We turn 4 as a fraction, we do 4 over 1. Example like 3. 3 is a whole number. To turn 3, we put 3 over 1. Adding fractions. So here's basically the algebraic version, right? If we have an arbitrary or like a made-up fraction, and we call it a, b, plus cd, what we have to do is we have to multiply b by d. Whatever we do to the bottom, we must do to the top. And we have to multiply d by b. Whatever we do to the bottom, we must do to the top. And we basically keep the same denominator and add the numerators. So here, right, this is how we do it. What it really means is that we got to make sure that both denominators are the same. We do this by finding the least common denominator, or the LCD. We write the fraction using the common denominator, add the numerators together, and keep the denominators the same. Simplify if possible. Same goes with subtracting, right? Similarly to addition, the formula looks like this, right? The same. We have AB minus CD, which means that we have to make sure the denominators are the same so we can subtract our numerators. So find the least common denominator, rewrite the fraction using the common denominator, subtract the numerators, but the denominators stay the same, simplify if possible. So these two formulas, they might look wonky, they might look strange. It's all right. Algebraically speaking, and when we're dealing with math, that's how you generally write it, but it's better to do problems and you'll see the whole picture. All right, multiplying fractions. We multiply fractions, it's much more easier. All we really have to do is if we have a fraction a over b and c over d, what we do is multiply the numerator, so a times c and b times d. And then we get ac over bd. Simplify if we have to. So like I said here, you will simply multiply the numerator with the numerator, so that's a times c, and the denominator, B times D. All right, dividing. Dividing is that little common trick that we always say, keep, change, flip, right? So what this means is we're going to keep the fraction, the first fraction. We're going to flip or change the sign. So instead of a division sign, we're actually going to do a multiplication sign. And then we're going to flip, or in math terms, it's called the reciprocal. We're going to flip that second fraction, and then we just multiply across. So notice how here we have a over b divided by x over y. We're going to keep this first fraction, which is a over b. Notice how we kept it here, a over b. This division sign becomes a multiplication. So this changes, and then we flip x over y. So x over y, if we were to flip it, becomes y over x, and then we multiply across a times y, b times x, b times x. All right, but the main gist of it, no point of like explaining all these weird letters if you can't really see it in practice. So I'm going to share my screen over here, and we're just going to go over some basic things. So let's go with 2 over, oops, sorry, I don't think I'm sharing my screen. Stop sharing. And let's look at, let me look at my other screen. Oh, sorry, bear with me. Trying to share 2 screens at the same time, 2 different laptops. Should be working. Okay, good. So, oops. We have, what was the first question? 2 over 5 plus 1 over 5. Right? So they already have the same denominator. So that's perfect. We got to keep it, right? So since they have the same denominator, here it's 5 and 5, we keep it, but we just add the numerator. So what is 2 plus 1? It's 3. So we have 3 over 5. We cannot simplify anything else. So it's 3 over 5. How do I delete this? Oops. All right, whatever. Next question. Next question is 1 plus 3 over 8, right? Like we said, how do I turn a whole number, which in this case is 1, into a fraction? Well, it's just going to be 1 over 1, right? 1 over 1 plus 3 over 8. So they do not have the same denominator, but we got to find the least common denominator. So what are the multiples of 1? We have 1 times 1, 1 times 2, 1 times 3, right? And we just say 1, we have 2, 3, 4. What about 8? We have 8, right? 16, and then so on. But if we were to realize, right, 8 is the least common denominator. So what that means is we're going to multiply. How many times do I have to multiply 1 to get 8? Well, that's 8 times. And whatever I do to the bottom, I must do to the top. So our new fraction becomes 8 over 8 plus 3 over 8. We keep the same denominator, so it's going to be 8. And then we just add the numerator. What's 8 plus 3? We do that real quick, and we get 11, right? One of our classmates actually said, do we have to keep it like this, or can we make it into a mixed number? And we can make it to a mixed number. How many times can 8 go into 11? That is 1 time, right? And then what's the remainder? 3. So we put 3 over 8, right? So when we turn it into a mixed number, you kind of just want to focus on 8, right? How many times can 8 go into 11? 1 time, right? But then what's the remainder? The remainder would be 3, right? Because 8 plus 3 will give you 11. We get 3 over 8. All right, let's look at a new one. We're gonna have 2 over 3 plus 1 over 5. I think that's the one that we had. What's the least common denominator? It's 15, right? Because 3, 6, 9, 12, 15. Then we have 5. We have 5, 10, 15. The multiples, right? How we multiply each other. We have 15 and 15. That's how they share it. So how many times do I have to multiply 3 to get 15? 5. Whatever I do to the bottom, I must do to the top. Next thing, how many times do I have to multiply 5 to get 15? And that is 3. Whatever I do to the bottom, I must do to the top. So we get the following. Let me kind of write this over here, right? It's 2 over 3 plus 1 over 5, right? This new one becomes what? 5 times 3 is going to be 15, so that's my new denominator. And then 2 times 5 is what? It is 10 plus 15, right? Because 5 times 3 is 15. And then what is 1 times 3? 3. We keep the same denominator, so it's 15. But then we add the numerators. What is 10 plus 3? It's 13. And that's how we get this one. Ooh, can I fill this with oops, never mind. Great. So that's how we do it. Uh, the following ones will be examples as well, but kind of follows the same point, right? We have to make sure the denominators are the same, so then we could add or subtract the numerators. So let's try another one. Let's try a subtracting one. So let's look at 5 subtracted by 1 over 4, right? What is 5 as a fraction? It's 5 over 1 minus 1 over 4, right? They both have to have the same denominator. So in this case, the least common denominator is 4. So I have to multiply 4 to the bottom and multiply 4 to the top. Our new fractions become what? 1 times 4 is 4. 5 times 4 is 20. Minus 1 over 4. We keep the same denominator, but then we do the numerator portion, right? Which is 20 minus 1, and that is 19. If we were to convert this into a mixed number, how many times can 4 go into 19? It's 4 times. So we're going to write 4. And then what's the remainder? 4 times 4 is 16. 19 minus 16 is 3. So the remainder is 3 over 4. All right. Let's try something else. Let's try 9 over 5 minus 5 over 8. All right. So here, let's say we don't know what the denominator is, right? What the least common denominator is. What we could do is always just multiply the denominators respectively. So here we could just multiply by 8. Here we could multiply by 8. Here we can multiply by 5. And here we can multiply by 5. And it might be a bigger number, but maybe we could simplify along the way. So what are our new fractions? Well, 5 times 8 is what? It's 40, right? And what is 9 times 8? 72. So it's 72 over 40 minus what is 5 times 5? 25. And what is 8 times 5? Well, it's going to be 40 as well, right? So we keep the same denominator, which is going to be 40. But then we do 72 minus 25. And what is that? Oops, sorry. How many times can 40 go into 47? One time. What's the remainder? 7 over 40. And that's one way we could do it. These two are both equivalent, so either of them would be correct, unless on the exam it says simplify. If it says simplify, please do it this way. Okay. Okay, now let's focus on multiplying. Multiplying is much more simpler, right? Let's say we have 2 over 3. We're going to multiply that by 4 over 5. All we really have to do is just multiply across, right? So it's going to be 2 times 4. So it's going to be 2 times 4 over 3 times 5. 3 times 5. What does that become? 2 times 4 is 8. 3 times 5 is 15. And we get our result. Likewise, even if we multiply with more fractions, let's say 2 over 5 times 1 over 4 times 5 over 6. We just multiply across. It's going to be 2 times 1 times 5 over 5 times 4 times 6. Right? We multiply across. 2 times 1 times 5 is going to be 10 over, then we have 4 times 5 times 6. And that's going to give us 120. right? They both share a 10, right? You see how here we could have a 10, and at the bottom we could have a 10. If we divide the top by 10 and divide the bottom by 10, you get what? 1 over 12. And that would be its simplest form. If we were to ask, hey, find this fraction in its simplest form, that would be its simplest form. Let's try some division. So let's say we have 3 over 2 divided by 10 over 7, right? So we know that rule, keep, change, flip. So let's keep the first fraction, which is 3 over 2. We're going to change that division into a multiplication sign. We're going to flip that 10 over 7. 10 over 7 now is going to be 7 over 10. And we just multiply across. 3 times 7 over 2 times 10, right? 3 times 7 is 21 over 2 times 10, which is 20. Simplify if you'd like. How many times can 20 go into 21? Well, it could go into it 1 time. What's the remainder? 1, and then we just keep the denominator the same. Okay. Let's go do another one just for practice. 9 over 5 divided by 3. Well, let's keep those air quotation marks again. Keep, change, flip. Right? We're going to keep the first fraction, which is going to be 9 over 5. We're going to change that division sign to a multiplication sign. And what is 3 flipped? Well, 3 as a fraction, right, is 3 over 1. So when we flip it, it should give us 1 over 3. So let me just make a little note there. Can I have a different color here? Sure. So 3 as a fraction is 3 over 1. When it gets flipped, it's going to be 1 over 3. Great. So now we just multiply across. 9 times 1 is going to be 9, and 5 times 3 is 15. They both have a 3, right? Because 3 times something will give you 9, right? So if you divide by 3, and we divide by 3 at the bottom, it should give us a simpler form. What is 9 divided by 3? Well, that's 3. And what is 15 divided by 3? That is 5. So we get our fraction. And basically, this is all we have to do when we're multiplying, dividing, adding, or subtracting. I guess it's adding and subtracting is kind of more tedious because we have to kind of find the least common denominator. But when we're multiplying and dividing, it's pretty straightforward. We just multiply the top and multiply the bottom. All right, so let's go back into the rest of the lesson. So I'm going to share. I'm going to stop sharing this. Let's go back to the PowerPoint. All right. So we did a couple of these, not all of them, but we did a fairly quite, a couple. So now we're off to percentages. Now, what does percentages or what are percentages? Percentage or percent is a ratio expressed as a fraction of 100. Percents tell us the likelihood something of something occurring. The closer you are to 100, the more likely it is to happen. The closer you are to 0, it's unlikely to happen, right? So if you were ever to use your weather app and it says, hey, there's, I don't know, it's 20% chance of rain. You're very close to 0. Well, you're not very close, but you're closer to 0. So chances are it's probably not going to rain, right? But if it says thunderstorm and there's a 89% chance that it's going to be a thunderstorm, bring an umbrella, right? Because it for sure might rain. There's a high possibility that it will rain. If you're at 100%, then that means it's for certain going to happen, right? If you're at 0%, that means it's impossible. It will never happen because there's 0% chance that it will happen. But that's usually what we use percentage for. Other ways that you'll see percentage is, when you're going, when you buy things, there's taxes, and those are percent. Don't remember what New York state tax is, but it's like 0.8 something. When you go out for a dinner and you have to pay a tax as well, or a tip when you want to include a tip. Other ways percentages are seen as discounts. So when you go to stores and you like a shirt and they're like, hey, there's 50% off, that's usually a good thing. That means you'll be saving money. But besides that, we have percents, right? And This is the percent formula that we saw in class. So it's basically percent times the base is equal to amount. So the percent you'll know because it has that percentage sign. The base is the base of the whole amount, and the amount is part of the whole. All right, converting decimals to fractions to percents. So if we have a fraction, right, we divide the numerator by the denominator and we'll have a decimal. Now, if I multiply that decimal by 100, I get a percentage. Now, let's say I have a percent. If I divide it by 100, I'll get a decimal. And then from that decimal, I can convert it into a fraction. Right, this is usually how it goes, but we'll actually do examples so we actually see how it happens. So let me exit out of this again. And let me just write some of the examples here. Actually, let me just. Okay, let me stop sharing. And let me share on this side. Bear with me, guys. I'm kind of like juggling between two different laptops. Okay, so let's look back at some of the examples. So we have 3 over 4. Let's turn it into a decimal first and then a fraction. So 3 over 4, if I were to have a calculator and do 3 divided by 4, I get the decimal 0.75. Right? The special thing about over 4 or a fraction that has a denominator 4 is think about quarters, right? You need 4 quarters to make a dollar. So if you have 1 over 4 or 1 quarter, you have 25. If you have 2 quarters, you have 50 cents or 0.50. If you have 3 quarters, you have 75 or 0.75. So this is the fraction. Then this is your decimal. And then let's turn into a percent. How do I turn into percent? Well, I have to multiply this by 100. So let's put 0.75 times 100, and that gives me 75%. If you don't have a calculator, all we could really do is just move the decimal places to the right 2 times. All right. I wish I could delete this like quickly. I can't. All right. Oh well. Oh, can I? Never mind. All right. What did I do? Oh well. Let's look at another question. Let's say we have 13 over 50, right? So let's divide 13 by 50, and I get 0.26. All right, so this is the fraction portion. I'm just going to denote it by F. This is the decimal portion, D. Let's put it into a percent. So how we turn to the percent? We just multiply by 100. So 0.26 times 100 is 26%. Let's look at a different example. Let's see a percentage. So I mean a decimal. So let's say I have the decimal 0.45. This is the decimal. Let's turn it into a percentage first, right? So what I'm going to do is actually multiply by 100. So 0.45 times 100, and that gives me 45%, right? Remember, percentage is out of 100, right? Percent per 100. So how do I turn it into a fraction? What did that say? Running out of time. Okay. It's gonna make me all right, we only have 9 minutes left, but whatever. So what we're gonna do is put it over 100. So that's gonna be 45 over 100. And that's how we make it into a fraction. All right. Let's resume to the next one. So let's say we have 345%, right? This is the percentage. Let's turn it into a decimal. right? So in order to turn it to decimal, that means we're going to divide it by 100. Right, so 4, 5, 3, 4, 5 divided by 100 will give me 3.45. I guess we kind of missed a step here too. Sorry. So, because if we were to write this as a fraction, then it would be 345 over 100. So I guess first we were supposed to turn into a fraction, and then once we divide it, it'll give us a decimal. Um, that's basically the gist of it, right? This will be on the exam, or not the exam, on the little quiz. So please do so, right? Uh, let's say we have 12%, right? This is the percentage. What is a fraction, right? Well, it's out of 100, so we do 12 over 100, right? When we do that, it's going to give us our decimal. 12 divided by 100 is 0.12. Okay, so then let's look back at our PowerPoint. Um, Now, using the percent equation, right? Uh, let's say we're asked the following: what is 20% of 150? Or what if they say what percent of 160 is 80, or 30 is 20% of what number? We have to use this. We have to use the percent times base times amount, and that will help us to figure out the following, questions. So let's work on that real quick. Stop sharing. Let's look at this. So say they say, what is 20% of 150? Well, my percent is 20%, right? And my base is 150, all right? Make sure I'm writing this correctly. Yes. And then the amount is unknown, right? So our formula tells us it's going to be the percent times the base is equal to the amount, right? So let's plug in what we know. 20% as a decimal is 0.20, right? Because you move the decimal space to the right by 2 times. We multiply, or you could just do 20 divided by 100, and that'll give you 0.20 times the base. What is the base? 150. All right. If we do 150 times 0.20, we get 30. So 20% of 150 is 30. It's like an ugly number. It's 30. All right. Let's look at another example. Let's see what's the next one that it said. It's what percent of 160 is 80? So I don't know my percentage, right? It's a big question mark. I know 160 is my base though. And I know my amount is 80. So I go back to my formula, percent times base is equal to amount. So I don't know what this is, so I'm just going to label it as a question mark. What's my base? My base is 160, and then my amount is 80. So whenever we have something that we're multiplying, it's kind of like dealing this with an x. We have to, in order to get these removed, we have to divide by 160 on both sides, right? Basic algebra. And we get that the question mark is equal to 80 divided by 60. Or 160, sorry. 80 divided by 160 is 5.5, sorry. So question mark, or our percent, is supposed to be 0.5, right? 0.5, a decimal, right? How do you turn it into a fraction? We multiply by 100. 0.5 times 100 is 50%. So that means the percent is 50%. So 50% of 160 is 80. What if they say 30 is 20% of what number, right? Well, same thing. We know the percent is 20. We know the base is unknown. We don't know what the base is. Base is unknown. The amount, however, is 30. So my formula, we have percent times base is equal to amount. We do 20%, which if we do 20 divided by 100 to get a decimal is 0.20 times x or times, a question mark because I don't know what it is equal to 30, right? These two things are together. In order to get multiplication rid of it, we have to actually divide by 0.20 on both sides. That's how we find a missing variable. What is 30 divided by 0.20? 30 divided by 0.20 is 150. So we found out that our base, right, or question mark is equal to 150. And now we know that one, or, this is now 150. So 20% of 150 is 30. That's what our question mark is now, or what our base is. We were able to figure that out using this formula. So we plug in what we know, or first we figure out what we do know, right? We know the percent, we knew the amount, then we plug that into our formula and we kind of figure out or solve for our base, our question mark.